Lesson 10.3, Properties and Logarithms. Now here are 8 different questions, and the questions all ask the same thing. Are they equivalent? If you were to go through all these and check for equivalency, only 3 of them would work. This is asking you to take 2 times 5 and get 10, and take the log of 10, which would give you 1. And then I want you to take the log of 2 and take it times the log of 5, and see if you get the same thing. And you would not. So in this exercise here, we're trying to figure out what are the properties of logarithms. And it is not this one. In other words, they tell you if you have 2 things being multiplied inside one log, you can separate them into 2 different logs. This one here says if you have a log of a division problem, you can have the log of the numerator over the log of the denominator. Also does not work. Next one you have, if it's log of 2 times 5, then you can have the log of 2 plus the log of 5. This one is true. Next one, it says if you have the log of 2 things being divided, you'd actually take the log of the numerator and subtract the log of the denominator. This is true. The next one says if you have something added inside here for logs, you can have the separate logs and added together. Not working. This one here, if you notice, again, subtraction, when 2 separate logs being subtracted, not working. Here you have log of 10 to the third. The power of 3 can go outside and have log 10, not working. Here it says if you have log of 10 to the third, the 3 can go to the front of it and have log 10. That one works. So these are your 3 properties that we're talking about with logarithms. What does that mean with letters? Okay, so the formulas that we're getting towards is this. If you have the log of something and inside that the parentheses is a product, then you can write that as, and here's what this one is, log of u plus the log of v. Now, I don't have it written in here, but we are assuming that if it was starting with base a, all of these have the same base. If you have division, the log of something being divided, that's right here. We would take the log of the numerator and subtract the log of the denominator. That is true. And again, if they have base a, all of these have the same base. Next one, if you have the log of something to a power, that power can come out to the front of it. Take it times the log of u, which again is base a. So multiplied. And this one doesn't work. Okay? So these are the 3 rules that we will use to manipulate equations. Now there's 2 types of questions you'll see, and that is that you have one equation where you have some logs present but not everywhere. So if all the terms do not have logs, then you are to reduce the equation down to a single log and then put it in exponential form. In other words, we're going to make this 1 log. Now here they're adding 2 separate logs, and up here it says that we could write it like this then, if they're adding 2 logs. So I will write log base 2 of their product, x times x plus 2 equals 3. Now, this is log base 2 of something equals 3. We can change this logarithmic notation into exponential notation. And that would be x plus 2 equals base 2 to the 3rd power. That gives us 8 on that side. We distribute, we get x squared plus 2x. We have a quadratic I bring the 8 to the left side by subtraction, and we can factor. So our two solutions here are -4 and 2. But what did we remember about x? X cannot be negative, so 2 is our solution. Next question. Again, we have 2 logs, but the other side does not have logs, so we're going to rewrite that. Again, they're being added. So we can say log base 2 of x times x minus 6 equals 4. That's a 6 right here. And then we can go to exponential notation. So we have x minus 6 equals 2 to the 4th power. We have x squared minus 6x to the 4th power is 16. Bring that over. And we factor it. Eight and 2. We have -2 and 8. Again, we can't have the negative. So 8 is our answer. Next is, what if you have an equation where all terms have logs? Then we're supposed to reduce each side to a single log, and then we can drop the logs. So this side we need to bring together. So we have log base 4 of 3x plus 2 equals. They're being added. So we'll say log base 4 of 5 times 3. Now we have log equal to log. And we've done this in the last couple of lessons. We can just drop the logs in and focus on the parentheses. We're not dividing by logs, it's just that they are equivalent statements. So for them to be equivalent, proven equivalent, we can just say, well, 3x plus 2 must equal 15. Solve for x by subtracting 2, dividing by 3, and x is 13/3. Next one, we have a couple things we need to take care of. First of all, we have this statement. This is one of the properties. This can be rewritten as log base 2 of x to the 4th. Minus log base 2 5 equals log base 2 of 125. And I think I'm going to stop here. This will be finishing 10.3 part A. You can watch part B right after this. And I'll finish the question.